Yeah, thank you. Thank you for, first of all, inviting me for this wonderful occasion. And it feels like I'm back in IRCS and Link days, giving a cliff talk. Yeah, so feel free to interrupt, as we used to. I'm going to talk about super tags and some new work, and I called it some new opportunities. Although this is work that I've been doing with Sumit Chopra, the work started with Dr. Joshi. I never managed to call him Aravind. Some reason, Dr. Joshi, that collocation is much better than Professor Joshi, even though Professor Joshi is probably appropriate. So I'm going to talk a little bit on, by the way of background, tell you a little bit on the idea of complex lexical descriptions, and step into a little bit on the curriculum learning work I've been doing. So the idea here, I think Tony alluded to, and I'm sure Bob Frank is going to talk a lot more about it, is the idea that a natural language description written in a context-free grammar is somehow linguistically not satisfying. Why do I say that? Because constraints such as subject-verb agreement constraints are distributed between two rules in a context-free grammar representation. And so do things like subcategorization. For example, by simply saying that fly is a verb, I can't impose that fly has to be an intransitive verb. It could go on and pick an object NP, and so I would have to specialize the non-terminals to have that constraint, and that's how sort of feature structures came about and to impose such constraints. So if you were to start unpacking those constraints, we would end up in something that couples the lexicon, which is the top part of that grammar there, with the bottom part, which is the syntax part. And so eventually, we kind of end up with these kinds of structures where the lexicon itself projects the syntax. So there's no distinction between lexicon and syntax. Now, why such structures, and why do you stop only at those structures and not expand those rules further are things that I'm sure Bob Frank will explain more. But the idea here is to localize the constraints to within an object of the grammar. So if you fold in these complex constraints into an object of a grammar, in these cases trees, you end up with these complex descriptions that are anchored in the lexicon, and there is no distinction between sort of syntax and lexicon. And these have interesting computational consequences that we explored, Dr. Joshi and I explored in the super tagging literature. So most of these new grammar formalisms, tag, CCG, HPSG, LFG, dependency grammars, these have the central idea of linking up the syntax and lexicon. The differences are how these descriptions, where do you stop them, how do you, how much to expand, how much to anchor in the lexicon, and how much to derive as part of the derivation process is something that differentiates these formalisms. So in particular, I'm going to talk a little bit on the super tags or tag-based descriptions. The idea here is that these are complex descriptions, again, anchored in the lexicon. They are richer than parts of speech, simple parts of speech, like nouns and verbs and adjectives and so on. As you saw, the word projected most of the syntax from the lexicon, so you will have many more descriptions per word than simple parts of speech. They also encode morphosyntactic constraints, so you can have feature structures operating within the object. You don't have to go across different objects of the grammar like we had to do it in context-free grammars. So things like subject-verb agreement constraints operate within that same object. Predicate argument constraints or relations like intransitive, ditransitive, subcategorization information is also folded in within that object. One thing that distinguishes tag-based super tags is that certain syntactic transformations, like the filler gap dependencies, are also localized within the grammar, within these objects. So things like relative clauses, WH extraction, and so on. So that's something that distinguishes tag from, for example, other grammar formalisms. The point where it sort of, as part of this expansion process, at some point you have to account for recursive structures in the language. And so these recursive structures are sort of factored out. They are separate objects that come as part of the derivation process. They don't get unfolded in the lexicon. And that's a choice that one needs to make to have a finite number of these objects to work with, because these recursive structures can operate on the elementary objects any number of times and create arbitrarily long strings. So these objects are in tag are combined with substitution and adjunction operation. So here are some examples of the elementary objects for active sentence, like John hit the ball, or the passive sentence, the ball was hit by John, or a WH extraction. And on the right-hand side, you see the ones which are recursive in nature, the preposition objects and adverbial super tags. So once you go down this path of unfolding certain items in the lexicon, you end up with a scenario of this sort, that given a sentence, you have a bunch of these descriptions that you pick up from the lexicon, and parsing becomes more like a jigsaw puzzle problem. So you have these elementary objects that are in the lexicon, but because of the many number of them in the lexicon, independent of the context of the sentence, you can't decide which one to pick. So that problem essentially became what we call now as super tagging, the idea of identifying the right lexical description given the context of the sentence, so that these super tags fit together. Is like a tagging problem, and we called it super tagging. And the name is something that Dr. Joshi and I were talking to Mark Lieberman, and he suggested that we should call it super tagging. And since then, people have used this name and had imaginative illustrations of super tags and Superman like pictures associated with it. So the essential idea is that once you localize these constraints within the lexicon, the task of parsing becomes almost like a tagging problem. So getting the identity of these units in the context of a sentence solves most of the parsing problem, and it's a matter of just stapling these objects together to create a parse of a sentence. And this is something that Dr. Joshi had suggested when I was looking at Yves Chabes's parser back in the 90s, and it was extremely slow. Sorry, Yves, wherever you are. And so I used to write these rules within the X-tag grammar system to eliminate obvious ways of eliminating wrong description, or descriptions that may not be used during the search the parser encounters. So we decided maybe we should look at the tagging literature. Part-of-speech tagging literature was up and coming then. And we looked at it and said, okay, maybe we should look at it as a tagging problem, except that these tags now can be unfolded. But even if you take it as a vocabulary of tags, instead of 50 tags or 47 tags in the Penn tree bank, we would have 5,000 tags or 500 tags, many more. So the ambiguity resolution problem is much more in super tags. So we started investigating different models. Back then, I looked at generative models. So the idea is given the sequence of words, can you pick the best sequence of tags such that some probability or some scoring function is maximized? And there are different ways of estimating parameters for this model. We looked at generative models then. More recently, people have looked at discriminative models. But the essential idea is that if you are able to identify constraints that are from a supervised corpus, from an annotated corpus, can we induce parameters of these distributions and eventually come up with a sequence of tags without doing a full parse of the sentence. We wanted to do a quick, first pass in a sense, and then feed it to the tag parser to speed up the parsing process itself. So the parameters, back when I was doing the part of the XTAG team, we did not have a big corpus, and thanks to Mitch and the Penn tree bank, a corpus came about where the trees, where the sentences were annotated with syntactic trees. So as part of my dissertation, with a need to estimate these parameters, I started ad hocly converting the Penn tree bank into a tag-based annotated corpus so that I could estimate these parameters. But in a sense, before I go on, more recently, like in 2012, NACL, Mari Ostendorf put up a slide called Super Tagging Legacy, and she illustrated all the various sub-disciplines within NLP that have used super tags or ideas of super tagging, from parsing to language modeling to machine translation and so on. So it was an impressive list of things that super tags have had an impact on. And Dr. Joshi and I had published this book, co-edited. It's a synthesis of various different ways of looking at super tags from different formalisms and various applications that have resulted from that. And that's a book that has came out in 2010 after some consternation, I guess. But for me, there's still a fly in the ointment in a sense, because I spent about 7 years, along with Christy and Beth Ann and other linguists and Tony Kroc, saying that our analysis in XTAG may or may not be right. And so we used to have a lot of debate about it. And then I went on to convert the Penn tree bank. So for me, it's still sort of not satisfying. And is the work that we did on XTAG not relevant? We haven't really exploited all the structures that we built for the past 6-7 years during that period. Kind of took a different turn. And Julia Hockenmeyer's work from converting the Penn tree bank into CCG and so on, it has had a life of its own. But still there is a dissatisfaction, at least in my mind, that we haven't exploited the XTAG grammar. And people in HPSG are also building grammars. What is the status of those grammars in the current times where people are building tree bank-based or extracted grammar-based systems? So with that in mind, a colleague who joined the labs recently and I started looking at an old task in part-of-speech tagging, which used to be called 5 minutes. Wow. Marialdo's task, which is essentially the idea is that instead of expecting an annotated corpus, if I were to give you an unannotated corpus with a dictionary that maps all the words with its tags, or be it part-of-speech tags or super tags, can we learn a model for tagging for that domain? So there is a number of previous work in this area. Kevin Knight has also worked with his student more recently. We started looking at it from a deep neural network way of addressing this problem. So the idea is that if I were to give you a dictionary with parts of speech or super tags, can we induce a tagging model without having to insist on an annotated corpus? So let me quickly go through a few slides on that work and sort of speculate on what the directions that we would like to explore. So most of the tagging literature can be thought of in terms of localist representation of words. that is, words that have their own individual representations. In the neural network community, they call it one-of K coding. So a bit in an n-dimensional vector is set for each word. But people in the NLP community have suggested that maybe we should represent it in a lower dimension and have distributed representation of words. The idea is that we take this high dimensional representation and embed it in lower dimensions. So you have a smaller dimension but dense vectors, and these are variously called as distributed similarity-based representations that Fernando and others have worked on. In the neural network community, the idea is that we want to induce these lower dimension representations not independent of the task, but in conjunction with the task. So in the task that we are looking at, it is part-of-speech tagging or super tagging. We want to induce these representations so as to maximize the performance on that task, as opposed to having just these representations stand by themselves. So in a sense, it's a coupling of an distributed representation of these words in conjunction with the classification model that happens together. So here's a representation of the lower dimensions in conjunction with a classification layer. In this case, it's a nonlinear classifier, a neural network classifier, and the outputs are clamped to the desired super tags or desired parts of speech tags. And we train these models. I'll spare you the details on how we go about training these models. But essential idea is that we have a phase where you fix the parameters of the embedding and then train the classifier to maximize the accuracy, and vice versa, and fix the parameters of the classifier and train the embedding parameters, and iterate until some convergence happens. So while we were looking at this problem, I mean, you can train this classifier with supervised data. We've done that for part-of-speech tagging. But the question is, can we do it for a task like the Marialdo task, which is a weakly supervised classification model? And we started training these models, and because of these models being heavily nonlinear and being vastly over-parameterized, this task of doing weakly supervised tagging was complicated. So we looked at this literature in neural network training, and one particular work from Bengio's group in Montreal is the idea of curriculum learning. So what if we structured the learning process so as to train on easy examples first before we get on to harder examples? It's an old idea in a sense in the AI community, but it has gotten a new visibility in the neural network community, partly because of the number of parameters that we need to train in these highly nonlinear models. So here's an example. You train a model for part-of-speech tagging, for example. You start off with words or training examples of words with single or no ambiguity in a sense, with single part of speech. Train the model until convergence, and then move on to two words with ambiguity 2, and so on. And so if you were to structure the learning process in this way, what we discovered is that, I mean, the details of the evaluation setup is here. What we discover is that a model that does not have this sort of structure sort of converges to a very high error rate, whereas a model that has the structure of curriculum goes through steps and eventually converges to a much lower error rate model. So, and here are some more numbers. I won't have time to discuss every one of these in detail, but the idea is that these are state-of-the-art, close to the state-of-the-art. I mean, Kevin is always ahead of the pack, but but the simplicity of the model, it seems like it's doing reasonably well. So we started looking at this same idea in the context of super tagging. So if we were to 0. Oh, okay. Well, All right, let me just take 2 more minutes. Right. Yes. So the idea of super tagging was that this, if you were to take the X tag super tags and do the same structuring, what do we get out of it? And you observe the same sort of phenomena, that the error rate drops as you structure the learning process. But the ambiguity, as you see, is much higher than in part-of-speech tagging. So here's the new opportunity. I think it's sort of a speculation here, but it's the beginning of an exploration. The way I described the way to structure the curriculum was primarily based on the ambiguity of the word. If the word has multiple tags, then it comes into the training process much later. But actually, super tags are much more interesting than simple parts of speech, because they're actually points in a very high-dimensional linguistic space. So you can ask the question, how should I explore simple super tags as in, active intransitive super tags from transitive super tags and then ditransitive super tags, or simply the active super tags versus passive ones, or transformationally related ones. So there's a much more interesting, space of exploration one can do in this space. One of the things that struck me was when I was reading Bob Frank's work on the time course of syntactic phenomena. Maybe there is something to explore there as to how you would, based on child language acquisition, how you would train these networks so as to mimic and have a cognitively plausible model of language learning. So before I conclude, I just wanted to say a few things about Dr. Joshi for me. We all know he's a top-rate computer scientist, computational linguist, psycholinguist, information theorist. Some of the things that he was doing didn't have a name when the field did not even exist. But for me, Dr. Joshi has been an artist of the top kind, because he endlessly perfects his masterpiece, which is, for me, is the derivation tree. The derivation structure that comes out of tag is extremely unique. No other formalism I can think of has that kind of derivation structure. And he painstakingly perfects it. We've had endless discussions about how these derivation structures can be interpreted, and the time course of these derivations have their own semantics associated with it. The other aspect of Dr. Joshi that impresses me the most is that he's a bold researcher. I've taken Shyamala's pictures, and although she didn't intend this interpretation, I'm giving that he's not a person who wants low-hanging fruit. He's an unconventional, bold researcher who takes, an umbrella to reach out to the high. One of the things that struck me was the work that he did with Seth Kulik. Back in those days, he came back from Europe, and he was trying to connect to the tag literature to the logical and logic-based proof trees, and he came up with this idea of stretching, which is remarkable. I would not have thought about combining proofs in a way of stretching them and like a rubber band and stuffing proofs within other proofs. This was remarkable. And finally, he is a true leader. He's been a mentor, teacher, and an advisor who never seeks the limelight. I don't know how the JoshiFest committee convinced him to have such an event, but thank you so much for everything that you've done.